Chapter 1.1, Day 2, Parent Function and Transformation. In this lesson, we are doing number 2, 3, and 4, where we have to graph the function and its parent function. So for number 2, the parent function for this graph is absolute value x, and the graph of this one is simple v, starting from 0, 0, go up 1 over 1 on both sides, and you're going to get the graph of a parent function. And the graph that is gx, I'm going to use a different color for that. The gx is absolute value x plus 3. So the gx value means that you're going to move the graph. So for this one, move up 3. So the same function, we are going to move 1, 2, and 3 unit up and follow the same characteristics, that is up 1 over 1, and graph the gx. So the red graph that I'm going to graph is the translated graph, where we move the original graph 3 units up. Now let's just do the number 3 here. The parent graph for this one is again absolute value. So the parent function is absolute value, and the graph is simply from 0, 0, go up 1 over 1 on both sides and make a original graph. And now we are going to graph the hx, that is our transformated function. So for hx, the graph, if the number is inside the x value, then we are going to move this graph some unit right or left. In this function, we are moving this graph to 2 units to the right. So if it is x minus h, then move right, and if it is x plus h, then move to the left. So in this case, x minus 2, you're going to move 2 units right, because this goes opposite. If it's a x plus h, we move to the left h unit. If it is negative, then we are going to move h unit right. So the same graph, that is a v graph, is moving 1 or 2 units to the right, and then use the same characteristics, up 1 over 1, up 1 over 1, and that is going to be your v graph, and that is a translated graph from the original graph. Question number 4. The question number 4, when we are going to make a parent graph, it's still the same, that is absolute value of x, and that is a v graph. And for the hx, so nx, you're using the absolute value graph reflection plus 4 units. So it means that you're going to do the reflection of the graph. Reflection, if you recall from the previous example, was the flipped down graph. So but it moved 4 units up. So here is 4 unit up here. From here, you, instead of going upward, you're going to go downward. So you're going down, and that's going to be your reflected graph. Again, for number 4, we did 2 translation. We did move the graph to 4 units up, that is 1, 2, 3, 4 here, and we also use the reflected graph. So reflected means that you flip the graph. If it is upward, that's the original graph, then you're going to make it downward because it's a negative and it's a reflection. Now let's just do the bottom part of this section, and that is vertical stretch and vertical shrink. Now for vertical stretch, when you multiply all y value or y coordinate by the same positive factor greater than 1, then the transformation is stretch. So if you multiply the function with 2, 3, 4, 5, or 6, or any number that is greater than 1, then it's called stretch or vertical stretch. Vertical shrink mean when you multiply all the y coordinate by the same positive factor but they are less than 1. So any factor that is 1 over 2, 1 over 3, 0 0.1, 0 0.2, 0 0.3, and so on and so forth. If you multiply with those values, then it's going to be a vertical shrink graph. Example number 4, graphing and describing stretches and shrinks. Graph each function and its parent function. So I already graphed the parent function. Remember, the parent function is for absolute value is this, and the points that you're going to use is 0, 0, 1, 1, 2, 2, and if you want to get the negative side, it's the same thing, that negative 1, 1 and negative 2, 2. Remember, these are the points that I got from the table when we made the table for parent function. Now, if you want to make the function that is 2 times y equals 2 times x, then each the point that you see, the y coordinate will be multiplied with 2. So the y coordinate of these points will be multiplied by 2. So the next point would be 0, 1 times 2, that is 2. So the next point would be 2, 2 times 2. Remember, we are multiplying the y coordinate by 2 to get the points for your 2 times absolute value x. So these are the new points we got for this function, that is gx, and we are going to now plot these points and get a new function. Remember, the first point is 0, 0, because 2 times 0 is 0. So I'm going to graph or plot this point right here. So it's going to be 0, 0. The next is going to be 1, 2. So this is going to be 1, 2. And then the next point is this one, that is 2, 4. So this is going to be 2, 4. Since this graph is a symmetrical figure, so either you make a point for the left side or just mirror these points. So this is one step to this, and then this is also one step to that, 1, 2, and that's right there. Either mirror these points from y-axis or make another table like we did here, and we are going to graph or plot those red points to get the new graph, that is a vertical stretch graph by a factor of 2. Now just think about the parent graph is this one, that is your v graph, that is raised by 1, and now the new graph, that is this red graph, that is gx, the y coordinate for this one is multiplied by 2. So this one original was 1 for y coordinate, and it's multiplied by 2. So the point that was originally 1, 1, now it become 1, 2. So originally the point that was 2, 2 become 2, 4, because the y coordinate was multiplied by 2. Next example, hx equals 1 over 2 absolute value x. Again, for the points that we got it from the table when we made a table, negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. Starting from 0, 0, it's a symmetrical figure. So 1, 1, 2, 2, 3, 3, like 4, 4, and on the other side, same thing. For the hx, which is 1 over 2 times absolute value x, you're going to now multiply each y coordinate by 1 over 2. So negative 2, this 2 divided by 2. Multiply 1 over 2 or divided by 2 is the same thing. So 1 over 2 times 2, that the point will give us, this one is negative 2, 1. And the next one is negative 1 comma half. The other one is 0 comma 0, because when you multiply 0 with any number, it's still 0. Next one is 1 comma, and when you multiply the y coordinate, that is 1 by half, you're gonna get 1 over 2. And when you multiply this one by half, you're going to get 2 over 2, that is 1. Same thing as this one. Now we're going to plot these points, and negative 2 comma 1 is this point right here. Next point is negative 1 comma half, that is this point. 0 comma 0. Next is 1 comma half, and the other one is 2 comma 1. So that's going to be a graph that is vertically by the factor of half, or 1 over 2.